have a quick quiz on Thursday. So, just as a reminder, and again, I don't know if Mrs. Ziggy did substitution on these with you. Maybe did a little bit of both and let you choose. I typically only do elimination. I just find it so much easier. So the first thing I would do is I would look at all of my x coefficients, my y coefficients, and my z coefficients and decide which one's going to be easiest to get these all to be the same number. And it kind of looks like it's 6 of one, half a dozen of the other. You know what that means? That expression, figure of speech. What does it mean, John? It really doesn't matter either way. If someone tells you to buy a half a dozen or to buy 6, it doesn't really matter. That's the same thing, right? Trivia. Okay. So that's what I meant by that. So it doesn't really matter. Let's just do the x's for the ease of, or maybe z's would be the easiest. Because 5, 3, and 2 would have to all become 30, right? Whereas 4, 2, and 3 can all become 12. So that's at least a smaller number. So let's do that. So in order for the 4, and who cares about the plus or minus right now? In order for that to become a 12, that needs to be multiplied by 3. In order for the 2z to become a 12, that needs to be multiplied by 6. And in order for the 3z to become a 12, that means it needs to be multiplied by a 4. I just prefer to get this multiplier out of the way and just rewrite the entire system so that I can just focus on that one. So my first equation is 15x minus 6y minus 12z equals 9. Second equation, 18x plus 18y plus 12z equals negative 18. And then negative 8x plus 20y plus 12z equals 12. There are people that would just multiply the second one and get it to be 4 and 4, so it matched the top. But then they would again have to re-multiply the second and third, this one by 3, this one by 2, to make it 6 and 6. I think it's just easier to do them all at once, get them all to be the same number, and then you don't have different pockets of work. It's all now just this system. So then the decision with elimination is, what am I going to do? And I'll start with the first two equations. Adding or subtracting, what will eliminate the 12s if one is negative and one is positive? Adding. I have a little slogan that's opposite signs means add, and same signs means subtract. So the negative 12 and the positive 12, those would be opposite signs. So the first two I'm going to add. That's 33x plus 12y equals negative 9. And then the second two equations, they have the same sign, positive 12 and positive 12. Same sign, so subtracting will eliminate those z's. So I'll subtract on those, and I, especially with subtraction, tend to write those negatives in there in between just so you don't miss a double sign, like right off the bat, 18 minus negative 8, 26x. 18 minus 20, negative 2y, negative 18 minus 12, negative 30. So I've eliminated the z twice, which leaves me with a system of just x's and y's. And so I have to do elimination one more time. So I always say there's 3 rounds of elimination. Eliminate the z once, eliminate the z twice a second time, and then decide which one's easier to get the coefficient the same on, the x or the y. This one's a no-brainer. Is it easier to get the same number in front of these x's or these y's? The y's. So multiply the second one by, the first one by 1, second one by 6. So 33x plus 12y equals negative 9 is untouched. And then your numbers are bigger, but 26 times 6, 156x minus 12y equals negative 180. And then are we adding or subtracting for this third round of elimination? adding. Very good. Opposite signs on the 12. Opposite signs means add. 189x equals negative 189. So that works out nice. X equals negative 1. Then it's just a domino effect backwards. So then I would go back, and in one of these previous equations with just x's and y's, I now know that x is negative 1. So I have a negative 26 that I'll add 26 to both sides. Divide by negative 2, so y equals 2. And then go back to one of your originals with x, y, and z. I'll just do the third one. Negative 2 times my x of negative 1 plus 5 times my y of 2 plus 3z equals 3. This will be 2 plus 10 plus 3z equals 3. Subtract my 12 over. 3z equals negative 9. Z equals negative 3. Okie doke. So sometimes you'll see your answers written as x, y, z, like negative 1, 2, and negative 3. Good? Okay. On the second one, just to capitalize on the fact that it's a little bit shortened, the first equation already is missing a y. So one round of elimination we don't actually have to do anymore because we already have one equation without a y, which pretty much directs us that on these next two, we should also eliminate the y. We're already missing a y. Let's eliminate this y. So this needs to be multiplied by what? 2, and this one, 1. So that gives us 2x plus 2y plus 4z equals 34. Second one's unchanged. Add or subtract. Same sign on the 2y's, subtract. So we have x plus 3z equals 18. And then I'm just going to move this one over. X plus z equals 8. So 3 rounds of elimination maximum. Sometimes if we can take advantage of something, we can do less. Because we only did one, and we only need to do one more. Easiest here, obviously, to eliminate the x's. They already have the same number, 1 and 1. Same sign on those ones, so same sign, subtract. So we get 1 minus 3 is negative 2z. 8 minus 18, negative 10. So z equals 5. Once you have that, go back. X plus 3 times 5 equals 18. Subtract your 15. We see that x is 3. And then bring both of them back to the original. 3 plus a 2y plus a z of 5 equals 16. That's 8 total, so I'm going to subtract 8 from both sides. And y equals 4. Any questions on that? Okay. Couple applications of a system. I'm going to guess you never did this last year, but if you're ever given 3 points, you can write the equation of a parabola. You wrote equations of parabolas with focuses and directrix. That for sure. Maybe you don't remember, but you did. That would be familiar. But I don't know that you ever did this, but it's real easy because you have a bunch of XY coordinate pairs. So for every XY coordinate pair that you plug into the structure of a quadratic, you have a 3-variable equation. So if I plug in 1, 4, I'm going to have 4 equals, and remember x is 1, so that would be 1a, plus x is 1, that would be 1b, plus c. That's the first point plugged in. The second point plugged in, an x of 2 and a y of 1, would be 1 equals a times 2 squared is going to be 4a. B times 2 is just going to be plus 2b plus c. And then if you plug in 3, 4, you're going to get 4 equals a times 3 squared is 9a plus 3b plus c. And what will always happen, because on the c value there's no attached x, is that we can eliminate our c's every single time. So the first 2 rounds of elimination, I have both 1c and 1c, so I'm going to subtract all these. That'll leave me with 3 equals negative 3a minus b. On the next 2, if I subtract my c's, subtract everything else as a result, 1 minus 4 is negative 3. 4 minus 9 is negative 5a. 2 minus 3 is negative b. And then again here, our third round of elimination, the b's already have the same coefficient. Add or subtract. Same sign, subtract. Right? They're both negative b's. Same signs, subtract. You're going to have to be careful here with your doubled up signs. 3 minus negative 3 is 6. Negative 3 plus 5 is 2a. And negative b minus itself is gone. So divide by 2, and a equals 3. Bring it back here, or to the top version if you'd like. That's a negative 15, so I'll add 15 to both sides. I get negative b equals 12, so b equals negative 12. And then bring them back to the original. 4 equals 9 times 3. Plus 3 times negative 12, plus c. That's a 27 minus a 36. So minus 9. Is that right? 27 minus 36. Add 9 to both sides. Good? Any questions? So we just now have to use those A's, B's, and C's to actually answer the question. The guts of the system part in the application is done. But we have to write the quadratic equation. So the quadratic equation is just y equals 3x squared, because A was 3, minus 12x, because B was negative 12, and then plus 13. And that quadratic contains all 3 of those points. Good? Okay. The very last one just looks a lot uglier. Really doesn't need to be, though. We just need to clear those fractions in each problem and then treat this like everything else. So on your first equation, what could you multiply both sides by that would clear a 2, a 2, a 4, and a 2? A 4. So if I multiply both sides by 4, on the left when I distribute, the 4 divided by the 2 is going to reduce to a 2 times the x plus 3 that's sitting there. On your second distribution, minus the 4 that's being divided by that 2 will also clear that fraction down to a 2 times y minus 1. On the third distribution, the 4 and the 4 will just cancel, so it'll just remain plus z plus 2. Equals, and this one you can either think of 4 times 3 halves being 12 halves, and 12 halves will become 6. Or you can think of, just like the other 3, the 4 and the 2 is going to reduce to 2 times the 3 that's sitting there will be 6. It's up to you. And then you would just clean that up to an x term, a y term, a z term equals a constant. So I'll do that. So this would be 2x plus 6 minus 2y plus 2 plus z plus 2 equals 6. So altogether we have a 2x minus a 2y plus a z equals, I'm going to subtract this 6 over, which will be gone, and subtract 4 more over, so it'll equal negative 4. And you're just going to clean up each equation until it sets up a system like what we were used to seeing in the beginning, but it's the same stuff. It's just an uglier way of presenting it. What would you multiply both sides by here? 2, 3, 4, and 6. What's the least common multiple of all of those? 12. So the 12 divided by 2 there is going to be 6 times the x minus 5. The 12 divided by 3 on the second one is going to be a 4 times the y plus 1. The 12 divided by 4 there is going to be a 3. And then 12 divided by 6 over here is 2 times the negative 25 would be negative 50. Do we get the point? We can stop there. So do that for all 3 of them. Line up the 3 nice versions of the system and solve your system that way. It's a little longer just because they make it out there. But all right, so your homework at the bottom, I'll let you get started on it now. And then also on the review packet, why don't we just do, this is probably the longest homework assignment of the week, so I'll just do anything that ends in a 9. We'll get rid of on the midterm review. And I'll